When it comes to space travel, you need to travel faster because all the points of interest are so far away. Researchers have always been trying to find a means to go faster than light in order to reach deep space more quickly. In fact, every technique explored has serious limitations, but researchers have uncovered a new way. How does it work? What are the requirements? How soon will you be able to travel with it? Join us as we introduce to you a new form of superfast travel. It would be challenging to see this video without light, which is both fascinating and crucial. We are able to walk without unexpectedly bumping into objects because of the sun and other artificial light sources that humans have created. However, you've probably heard that light travels quickly. But how quick is light? It's interesting to note that the foundation for most other measurements is the exact speed of light, which is known. In a vacuum, light moves at a precise speed of 299,792,458 meters per second. That means light will travel about 186,282 miles in just 1 second. When you turn on a light in a dark room, the light fills the entire space almost immediately, and you won't even notice that it is moving. This is because light moves so quickly. The light year, which represents the distance light can travel in a year, is another unit of measurement related to light. This amount equates to roughly 6 trillion miles. It is one method by which astronomers and physicists gauge the vast distances present across the cosmos. As was previously said, the universe is so big that it can take years for light to travel between 2 points. For example, the moon is roughly 1 light second away if light travels from the moon to our eyes in 1 second. Researchers have looked for a way of traveling faster than light. This is interesting since it means that humanity will eventually exist on other planets. We can travel to distant planets at the speed of light in less than 4 minutes. To achieve moving at a very fast speed, researchers have experimented with a variety of techniques. However, there has always been a problem that other solutions could not address, until a scientist revealed the brand new finding we will share with you in this video. It's extremely difficult to even approach 1% of the speed of light. This sounds like the stuff of science fiction, but spaceships that travel at this speed are possible, according to one top scientist. In a recent study, physicist Dr. Eric Lentz outlined a way that a rocket could theoretically travel faster than light, or over 186,000 miles per second. At that speed, astronauts could reach other star systems in just a few years, allowing humanity to colonize faraway planets. Just like Elon Musk, who plans to colonize Mars. Proxima Centauri, the star closest to our Sun, would take around 6,300 years for modern rocket technology to approach. There have been previous proposals for so-called warp drives, but they frequently rely on theoretical systems that defy physics. That's because nothing can physically move faster than the speed of light, according to Einstein's general theory of relativity. The other problem in a single word is energy. Any object moving has energy due to its motion, and physicists call this kinetic energy. To go faster, you need to increase kinetic energy. The problem is that it takes a lot of kinetic energy to increase speed. To make something go twice as fast takes 4 times the energy. Making something go 3 times as fast requires 9 times the energy, and so on. Consider the M drive as an example. It was hailed as the innovation that would swiftly transport us to the farthest reaches of the cosmos. This creation has even received a patent. In theory, it operates by enclosing microwaves in a shaped chamber, where their bouncing generates propulsion. Since there is no fuel input and no production of thrust, the closed chamber will appear to be moving by itself from the outside. The M drive relies on Newton's second law, where force is defined as the rate of change of momentum. An electromagnetic wave has a specific momentum that it can transfer to a reflector at the speed of light, producing a little force. The M drive, which appears straightforward yet fundamentally flips our understanding of physics on its head, is made possible by this accumulated little force in huge amounts. We wonder how the waves begin to move, how they keep moving, and where their impetus comes from because there is no energy going in or coming out. Without an understandable push, spontaneously generated momentum is impossible, which is why many scientists don't even consider the M drive to be a viable alternative. If the M drive is successful, a lot of what physicists believe to be true about the cosmos is disproven. Even Dresden University of Technology physicists tested the M drive, and the outcomes were promising. Propulsion data gathered by NASA and Chinese scientists all turned out to be false positives caused by outside causes. However, Dr. Eric Lentz, a physicist with more than 10 years of practical experience, has shown that the warp drive has a lot of potential. Lentz was the first to work on developing the warp drive beyond the realm of pure science fiction. The first person to try it was a Mexican mathematician, Miguel Alcubierre. The official warp drive literature was built on the basis of his idea, which was accepted in 1994. The name is Alcubierre warp drive. It has come to be known that, in addition to the dreaded alien matter as a co-ingredient, takes a staggering quantity of energy. Researchers haven't ever seen this highly radioactive material in nature, much less developed it. It's all just theory. Since then, a few modifications have been proposed, including one by Dr. Harold G. Sonny White, a former NASA engineer, in 2010 to the Alcubierre drive's physical design. Although it was still unworkable, his update decreased the quantity of energy required and also greatly decreased the amount of exotic matter required compared to the Alcubierre approach. A different team of Swiss researchers by the name of Applied Physics, or APL, presented their own theory. It's interesting that their drive's warp bubble may be created without using any unique materials. Though reaching the speed of light is the ultimate goal of space travel, their model was unable to do it. Lentz begins by referencing the physical construction of the traditional Alcubierre drive, on which practically all other solutions are more or less based, to illustrate how his idea differs from those that have already been put out. According to him, the Alcubierre solution gave a clear illustration of what a warp drive would do, which is to constrict the space directly in front of the ship or transport center section, and to expand the space directly behind. This shows the warp drive as a wave of curvature, on which a ship will ride to its destination. Lentz contends that while being the foundation of warp travel, it is not even the most important component. He claims that an answer put forth by scientist José Notario in 2002 demonstrated that the expansion and contraction were not required to move the ship ahead. He had to reconsider how a warp could be made utilizing only regular matter and not exotic matter as a result of his efforts. Notario was able to demonstrate that the expansion might be insignificant, or nil everywhere, and still accomplish the same objective of moving a ship. This is an important development, because it eliminates the need for the exotic matter that nearly all theoretical warp drive solutions use to warp the space in front of and behind the potential passenger. By building on Notario's theory, Lentz created his own variation that he believes is even more viable, because it is rooted in conventional physics. Lentz stated that his method differs geometrically from Alcubierre and most others because of how the energy is distributed around the warp bubble. Aside from this significant material distinction, the energy is contained in a tiny torus between the areas of strong contraction and expansion in the Alcubierre solution, where the energy density and curvatures are separated from one another to the maximum extent possible. Instead, Lentz's model has closely associated curvatures and sources, with nearly perfect overlaps between the high energy density and high expansion and contraction zones. The geometric differences between his idea and the conventional ideas make Lentz's suggestion a potentially more workable warp solution than those previously proposed. Lentz's warp drive is still only a theory. However, he does see some immediate actions that may be taken to try to bring his theory closer to reality, which, like all prior drive hypotheses, includes lowering the amount of energy required. From here, where does Lentz want to direct his warp drive? The next goal is to use a modern fission reactor to create a warp bubble that is capable of traveling at 1% the speed of light. The physicist stated that he would think about patenting his warp drive, but made it clear that his work is only a small portion of a broader, quickly and expanding body of work in this area, and that the recent rise in new warp drive concepts is not his work alone. Alcubierre's concept from 1994 inspires people working in his field, with the hope that an actual, testable version may be closer than we believe. Lentz said it has been exciting to see how much progress has recently been made in the field of warp drive. He thinks many more advances are ready to be made, and looks forward to seeing what the next few years bring. Let's hear what you think of speed of light travel in the comment section below.